Welcome back, deep divers. Today, we're going to be heading out to the Pacific Northwest.
Ooh, sounds nice.
Right. We're going to explore a topic that's been, well, it's been making waves lately.
Literally.
Hey, yeah, literally and figuratively. We're talking about the Cascadia megathrust.
Oh, okay.
You guys have sent in some really interesting articles about some fascinating,
Siri.
yeah, kind of scary, new research on this massive fault line.
Yeah, it's a big good one.
So let's unpack this, okay?
Yeah.
Let's figure out why scientists are so suddenly focused on this particular stretch of the West Coast.
Well, and you said making waves, and that's a good point because one of the things that makes Cascadia so unique, so dangerous, is that it's capable of generating just monstrous tsunamis.
Right.
But we'll get to those. Let's paint a picture, okay? Imagine like this massive crack in the Earth's crust, stretching for hundreds of miles along the coast.
Hundreds of miles.
Yeah, from Northern California all the way up to Vancouver Island.
Wow.
That's the Cascadia Subduction Zone, and that's where the Juan de Fuca plate...
Okay, hold on. Subduction zone.
Right.
I think some people might be picturing. Like the San Andreas Fault.
Oh, yeah.
Famous for those side-to-side earthquakes. What's different about a subduction zone?
Yeah, no, that's a great point. It's a really crucial distinction. Instead of sliding past each other horizontally like the San Andreas,
Right.
in a subduction zone, one plate is actually diving beneath the other.
Underneath.
Yeah, so think of it like a slow-motion collision, where the denser oceanic plate, in this case the Juan de Fuca, is being forced under the continental plate.
Mm-hmm.
And that process, all that grinding and pushing, builds up incredible amounts of stress over time.
So it's like a pressure cooker just waiting to blow.
Exactly. And when that pressure finally releases, it does so in the form of an earthquake.
Okay.
But here's the catch with Cascadia. Unlike other active fault lines that are constantly rumbling with smaller quakes,
Right.
this one is eerily quiet. It's like this sleeping giant. And that lack of seismic activity makes it even more difficult to study and predict its behavior.
Okay, so we've got this silent giant of a fault capable of producing these massive earthquakes.
Yeah.
But what's all this buzz about segmentation?
Oh, yeah.
One of the articles you sent in mentions some groundbreaking research from 2021
Yeah.
that really shook things up, so to speak. So what's the deal?
Well, so that research was really cool. They used this state-of-the-art research vessel called the Marcus G. Langseth,
Okay.
and it essentially gave us the most detailed ultrasound of Cascadia we've ever had.
Really?
And what they found was that this isn't just one giant crack in the Earth's crust. It's actually segmented, like almost like a series of interconnected fault lines running along the coast.
Okay, so why is that such a big deal? Does it mean smaller earthquakes?
No, it's complicated. That's why this research was so significant. Scientists had theorized about segmentation for years, but this study provided concrete evidence, and what it revealed was fascinating.
Okay.
Imagine a zipper with, like, some teeth missing.
Okay.
It can only unzip so far, right?
Right.
Those breaks or segments in the fault can actually limit how far a rupture travels during an earthquake.
So in some ways, segmentation could be a good thing, like built-in shock absorbers.
Exactly. It's like the fault has its own braking system, but, and this is a big but,
Okay.
not all segments are created equal.
Right.
The research identified one segment in particular. It stretches from southern Vancouver Island through Washington State, and it's smoother and more continuous than the others.
Uh-oh. That doesn't sound good.
No, it doesn't. Think of it like this. A steeper ramp will stop a ball from rolling very far,
Right.
but a shallower ramp lets the ball go much further.
I see.
And that's what we're dealing with here.
Oh.
This smoother, more shallowly angled segment means that earthquakes originating there could propagate much further inland, potentially impacting major cities like Seattle and Vancouver much more severely than we previously thought.
This is all pretty heavy stuff. I'm already feeling the need for a stress ball here.
Yeah.
But before we get to the what do we do about it part of this conversation,
Sure.
there's one more thing I want to touch on from the articles.
Yeah.
You mentioned tsunamis earlier.
Right.
And there was something about smaller faults closer to the coast that really caught my eye. What's the story there?
Yeah, this was one of the most surprising findings from the Marcus G. Langseth research. They discovered a network of previously unknown faults.
Wow.
Much smaller than the megathrust itself, running closer to the coastline.
Okay.
Now, these faults, they might not cause those mega earthquakes we associate with Cascadia,
Right.
but they pose a different kind of threat.
Okay.
Imagine this. A smaller earthquake, maybe not even that strong in terms of ground shaking,
Uh,
But because it occurs on a fault that's close to the coast and at a shallower depth,
yeah.
it displaces a massive amount of water, generating a tsunami that hits the shore with very little warning.
So it's almost like a double whammy. The
Yeah.
megathrust is looming out there,
Yeah.
capable of these massive tsunamis that we hear about.
Right.
But then these smaller, closer to shore faults could trigger faster-moving tsunamis
Yes.
with even less warning time. That's terrifying.
It's definitely a concern. And it highlights the importance of understanding the full range of potential hazards associated with Cascadia.
Right.
This isn't just about predicting the big one anymore. It's about recognizing that a whole spectrum of earthquake events,
Yeah.
each with its own unique characteristics, could impact the region.
This is all a lot to process, but fascinating nonetheless. If you're finding this deep dive into Cascadia as gripping as I am, hit that subscribe button on MindSpark Science Now, so you don't miss out on future explorations like this.
Please do.
And don't forget to give this episode a like and share it with your friends.
Spread the word.
The more we know about the forces shaping our world, the better prepared we can be. Now, before we move on to part 2, let's take a quick look at what life was like on the Pacific Northwest coast before scientists even knew about Cascadia.
You know, it's fascinating to think that for centuries, people lived along this coastline completely unaware of the powerful forces at play beneath their feet.
Right.
Like, it wasn't until the late 20th century that scientists even began to understand the true nature of Cascadia.
Yeah, I was reading about that in one of the articles you sent. Apparently, the first clues came from Japan.
Oh, wow.
Isn't that wild?
Yeah.
Scientists were studying historical records of tsunamis that had struck the Japanese coast.
Uh-huh.
And they noticed this pattern. These orphan tsunamis, as they called them, with no apparent earthquake source anywhere near Japan,
Yeah.
seemed to occur on a roughly 300-year cycle.
Interesting.
And then they started piecing together geological evidence along the Pacific Northwest coast.
Whoa.
Things like submerged forests and coastal landforms that indicated massive subsidence.
Right.
And it all kind of pointed back to a massive earthquake in the Cascadia region in January of 1700.
That's right. It was like a detective story, with scientists from all these different fields coming together to unravel this ancient mystery. And what they discovered was truly remarkable. The Cascadia earthquake of 1700, it was a mega event, estimated to be around magnitude 9, possibly even larger.
Wow.
It ruptured the entire length of the subduction zone.
The whole thing.
Yeah, sending shockwaves across the continent and generating a tsunami that traveled all the way across the Pacific Ocean,
Oh my gosh.
causing damage as far away as Japan.
Wow, a magnitude 9 earthquake and a trans-Pacific tsunami.
Yeah.
It's hard to even fathom the scale of that event.
It's huge.
But, here's what really struck me.
What's that?
The articles mentioned that this wasn't just a geological event, it was a cultural one, too.
Oh, interesting.
Native American communities along the coast had oral histories passed down through generations that described this catastrophic earthquake and tsunami.
Absolutely. Those oral histories provide a really vital human dimension to our understanding of the 1700 earthquake.
Yeah.
They describe villages being swept away, entire forests vanishing beneath the waves, and the landscape just permanently altered. You know, it's a powerful reminder that these events, they're not just abstract scientific concepts.
Right.
They have profound and lasting impacts on human societies.
It's amazing how those stories survived for centuries.
I know.
A testament to the importance of oral tradition in preserving knowledge.
Right.
But it also makes you wonder, if it happened before, it can happen again.
Well, yeah.
And what would that mean for the millions of people who live along the Cascadia coastline today?
That's the question that keeps scientists and emergency planners up at night.
Like them?
You know, we know that Cascadia is capable of producing these massive earthquakes, and we know those earthquakes can trigger devastating tsunamis.
Yeah.
The geological record tells us that these events occur on average every few hundred years, but we can't predict exactly when the next one will strike. It could be tomorrow, it could be a century from now.
That uncertainty must be incredibly frustrating,
Oh, absolutely.
both for the scientists trying to understand Cascadia and for the people just living in its shadow. But knowing what we know now, isn't there anything we can do to prepare?
Absolutely. And that's where things get really interesting.
Okay.
This deep dive, it isn't just about understanding the science of Cascadia.
Right.
It's about empowering you with the knowledge that can help you take action.
Okay, I like that.
Because while we can't control when or where an earthquake happens, we can control how we prepare for it.
Right.
And that preparation, both on an individual and community level, can make all the difference when the next big one
This
hits.
is what I love about science.
What's that?
It's not just about knowledge for knowledge's sake. It's about using that knowledge to make informed decisions and create a safer world.
Couldn't agree more.
And speaking of learning, if you're finding this deep dive as fascinating as we are, make sure you hit that subscribe button on MindSpark, Science Now, so you don't miss any future explorations of the science that shapes our world.
Yes, please do.
And don't forget to like this episode and share it with your friends.
Yeah, spread the word.
Spreading awareness is one of the most powerful tools we have in building a more resilient future.
Absolutely.
Now, let's shift our focus to what we can actually do to prepare for the inevitable. Because knowing about Cascadia is only helpful if we use that knowledge to take action. Okay, so we've covered the what, this just incredible subduction zone,
Yeah.
capable of unleashing these mega earthquakes and tsunamis. But what about the so what? What can we actually do with this knowledge? I think that's what a lot of you are wondering. How do we prepare for something as massive and unpredictable as a Cascadia earthquake?
Well, you're absolutely right. That's the crucial question.
Right.
And the good news is, even though we can't control when or where an earthquake happens, we can control how we prepare for it.
Right.
And that preparedness, both on an individual and a community level, can dramatically increase our resilience and our chances of survival.
So let's break it down. What are some concrete steps that people can take starting today to be better prepared?
It starts with the basics, like things you've probably heard before, but they're worth repeating. Securing heavy objects that could fall during an earthquake.
Right.
Having a family emergency plan so everyone knows what to do and where to meet. And putting together a well-stocked emergency kit.
Okay, those are the essentials. But when we're talking about Cascadia, it sounds like we need to go beyond just surviving the initial shaking.
Yeah.
We need to be ready for those tsunamis, potentially with very little warning.
Exactly. If you live in a coastal area, knowing your evacuation routes and having a plan for getting to higher ground quickly is absolutely crucial.
Right.
Remember, those smaller faults closer to shore, they could trigger a tsunami much faster than a deeper megathrust quake.
Right.
So every second counts.
This makes me think about the importance of community preparedness, too.
Sure.
What can towns and cities do to prepare for a Cascadia event?
Well, there's a lot that can be done on a community level.
Okay.
Strengthening building codes so new structures can withstand stronger shaking.
Okay.
Retrofitting older buildings and critical infrastructure like bridges and hospitals to make them more resilient.
And developing early warning systems that can give people those precious few extra minutes to take cover or evacuate. These are all key strategies.
Early warning systems, that sounds like a game changer.
Yeah.
Are those already in place for Cascadia?
They're being developed and improved all the time.
Okay.
These systems use a network of sensors to detect the first signs of an earthquake.
Right.
And then send out alerts through things like text messages, sirens, other channels.
Wow.
While they can't predict earthquakes, they can provide valuable seconds or even minutes of warning, which can be enough time to take cover, move away from windows, or even start evacuating.
It's incredible how technology can be harnessed to mitigate these risks.
It really is.
But even with the best technology, it still comes down to people being aware and knowing what to do.
Absolutely. Community education and outreach are vital. Conducting earthquake drills, providing resources on how to prepare emergency kits and develop evacuation plans, and raising awareness about the specific risks posed by Cascadia. These are all things that communities can do to empower their citizens. You know, it's striking how this conversation has shifted from this seemingly abstract geological phenomenon to these very concrete, actionable steps that we can all take. It feels empowering, knowing that we're not just passive bystanders in the face of these powerful forces.
That's the spirit. Knowledge is power.
Right.
And the more we understand about the world around us, the better equipped we are to navigate its challenges.
Absolutely.
And remember, preparedness. It isn't just about checking items off a list. It's about fostering a culture of resilience where individuals and communities are actively engaged in understanding and mitigating risks.
Well said. This deep dive has been a real eye-opener for me.
Good.
And I hope it has been for you, too.
Me too.
We've explored the fascinating science of Cascadia, delved into its history,
Right.
and most importantly, talked about what we can all do to prepare for its uncertain future.
It's been a great deep dive.
If you're hungry for more deep dives into the science that shapes our world, don't forget to hit that subscribe button on MindSpark. Science Now, We've got a whole universe of fascinating topics waiting to be explored.
Definitely.
And don't forget to like this episode and share it with your friends. The more we spread awareness about Cascadia, the more empowered we'll be as a community to face its challenges.
Thanks for joining us.
Until next time, stay curious, stay informed, and stay safe.